Good day, my viewers at home. We are presented with another question which deals with problems solved in the world of rotation. Now, in this question wishes to what? To make us to have a clearer understanding of how we can use the kinematics of rotation to describe the motion of what? A rigid body. And also on how to use some of the dynamics of rotation to describe or to discuss the motion of what? The rotational motion of a rigid body. Please remember the difference between dynamics and kinematics. Recall the difference between dynamics and what? Kinematics. Dynamics or kinematics, first and foremost, deals with what? Those mathematical equations that are used to describe the motion of a body without making reference to the causes of the what? Of the motion. Examples of kinematics in terms of translational motion we gave in chapter 3 of our material is the one we have as a V equals U plus what? AT. But in the world of rotation, we can transform that V equals U plus AT as what? W equals W naught plus alpha t. We have shown all these things in the previous episode. So if you have not watched the previous episode, please just make sure that you click back and watch the previous episode where we discussed about the kinematics of what? Of rotation. Then in terms of the dynamics, we're talking about dynamics of rotation now. We're talking about those equations that can be used to describe motion without, and also considers the causes of the what? Of the motion. All right, so we also talked about the dynamics of what? Of a rigid body, which deals with what? Those mathematical equations that can be used to describe the motion of a rigid body undergoing rotation, and then also considers the what? The causes of the motion. So this question we are about to solve now combines the two ideas of kinematics of rotation and dynamics of what? Rotation. Now, the question says that what? That a record what? Player turntable. That is a record player turntable. That is now, it's just like a disc. This is just like a disc. It's of mass. The mass of the turntable is what? The mass of the turntable is given as 2 kg. So let us bring out the parameters. We have the mass given. The mass M is given as 2 kg for the turntable. And what again? The diameter. Diameter is given in centimeters. So we have the diameter D was given as 34 cm. And what again do I have? It now says what? From an initial speed of this. The speed they are referring to here is not linear speed. They are referring to the what? To the angular what? Angular what? Speed. That is W naught. The initial angular what? Velocity or the angular speed. So my initial angular what? Velocity, which is W naught, is equals to what? 3.5 radians per what? Per seconds. And what again do I have? It makes, from an initial speed of this, it makes 3 complete revolutions. It makes 3 complete what? Revolutions. That is the number of cycles. It covers 3 cycles. It covers 3 cycles using this initial speed. So this 3 cycle now talks about the angular what? Displacement covered. So the angular displacement covered, which is my theta, is equals to what? 3 revolutions. But remember that angular displacement is not actually the standard unit of angular displacement in the world of rotation is in what? It's in radians. So there is a relationship between what? There is a relationship between measurement in radians and what? Measurement in what? In revolution. Because 1 revolution is equals to what? 360 degrees. And 360 degrees in mathematics is equals to what? Is equals to 2 pi radians. So we can convert from revolutions to what? To radians, which is the standard unit. All right. What again do I have? I also have that before it comes to rest. So once the record player comes to rest, that means the final speed there is what? Is 0. So that means it has a final speed of what? Of 0. Why we are using W here is because the record player is what? Is turning. It is turning, it is rotating. So it is undergoing rotational what? Motion. So we no longer talk about linear speed or linear velocity. We now use what? Angular what? Velocity and angular what? Angular speed. So we talk about initial angular velocity, which is W or rho, and what? And the final angular what? Velocity. So since the body came to rest, even when we are discussing about translational motion, once a body is moving with a speed and then comes to rest, once the body comes to rest, the final velocity is what? Is 0. But if the body starts from rest, the initial velocity is what? Is 0. So in this case now, this turntable, this body undergoing rotational motion, came to rest, which means that the final speed or the final velocity must be what? Must be 0. That's why we have your W here as what? As 0. Let's go ahead. It came to rest when it is switched off. The first question now says we should calculate the what? The angular what? Momentum. Very simple. The angular momentum. Second question, the time taken for it to come to rest after it is switched off. Read the questions carefully well. The time taken for it to come to rest after it is switched off. Number what? Number 3. That is, when you say the time taken, that means the time it took the turntable to cover these 3 revolutions. 3 complete what? Revolutions. That is what is required there. Then question 4 or question 3 talks about what? The moment of what? Of inertia. The moment of inertia of the turntable about its axis. Then number 4 is the torque acting on the what? On the table after it is switched off. So all these things comprises of the kinematics and the what? Dynamics of rotation. What I mean is that for us to solve these problems, we need to be familiar with those kinematics, those formulas we gave. Those formulas we gave that can be used to describe the motion of what? Rotation, without making reference to the causes of the what? Of the motion. So kinematics is a mathematical formula. It's an equation, any equation that can be used to describe the motion of what? Of any what? Body, without making reference to the causes of the what? Motion. So we are going to be using all those equations to solve this problem. So this aspect is more mathematical than physics. So the physics part has been discussed in the previous episodes. So here we are looking at how we can solve problems in the world of rotation by using those mathematical derivations to make our problems become simplified. So I will solve this problem as we have it on the board. Now, the first question is talking about what? It's talking about angular momentum. For you to know the formula for angular momentum, you need to know the comparison between translational motion and what? And rotation. You must know the what? You must be able to compare each of the formulas used in translation to the formulas used in what? In rotation. Now, linear momentum. We talk about momentum in the world of translation. That is in one-dimensional motion. Linear momentum is represented as what? As rho. And it is given as what? As the mass times the what? Times the velocity. But in this case, this one is in the world of translation. In the world of translation. One-dimensional motion. But in the world of rotation, what is the equivalence of what? Of momentum. Momentum is given as angular momentum, which we use the symbol big L for it. But remember that in the world of rotation, mass is replaced as what? Inertia. So therefore, instead of using mass here, we can use what? I, inertia. And again, in the world of rotation, linear velocity is replaced as what? Angular what? Velocity. So which we use as our what? As our W. So what it means is that in terms of rotation, angular momentum is equals to the product of the what? Of the moment of inertia and the what? And the angular what? Velocity. So for us to find the angular momentum, we must know the inertia of that particular what? Disk. And we must know the what? We must know the angular what? Velocity. Now the angular velocity is given to us. What is the value there? The value for the velocity was what? Was 3.5 radians per second. So we can now say where Now remember the inertia of a disk, because this is a disk, it's a disk rotating, because you have a record player now, just like a disk, you watch the thing as it rotates. As you slot in the disk, it will be rotating, so the thing will not be playing. So the moment of inertia of a disk, maybe about the center of a gravity, the formula, if you can remember, the formula was given as what? Half m arrow what? Arrow squared. Where arrow here implies the what? The radius. So therefore, we can now say that what? That our L will now be equals to what? Half m arrow squared times our W. Half m arrow squared times what? Our W. Where, remember, we are given the mass of the what? Of the turntable. What's the mass? Okay, we'll have it here. The mass was 2 kg, 2 kilogram. And what again do I need? The angular velocity, W. The angular what? Velocity, W, was given as what? It was given as 3.5 radians per what? Per second. And then what again am I giving? Instead of giving me you see, these people are very, very trickish. Instead of giving us the value of the radius, they gave us the what? The diameter. But remember that radius is what? Half of what? A diameter. So therefore, to find the radius, we must divide by what? Divide by 2. So our radius will be equals to the diameter over what? Over 2. Which is simply equals to 34 over what? 2, which will give us what? Which will give us, I think, 17 centimeter. And when you convert this 17 centimeter to meters, that will simply give us 17 by what? 10 raised per minus 2 meters. So these are the things we need to solve this question. These are the things we require to solve the question. So now, permit me, I have to clean this side so that we can have space to solve the problem properly well. So these are the parameters given to me. So now, this now means that my angular velocity, my angular what? Angular momentum, will now be equals to half times the mass, which I have as what? 2 kg, times the square of the radius, that is 17 by 10 raised to the power minus 2, all squared, times what is my angular velocity? Angular velocity is 3.5. So this now means that the angular momentum will now be equals to, even these two can cancel these two now. So that will now give us, let me see, I can use my calculator and punch this to get my required answer to this question. All right, let me get my calculator. Okay, I think maybe when you calculate this properly well, you get this as what? Okay, this is into bracket 17 by what? By 10 raised to the power what? 10 raised to the power minus what? Minus 2, close brackets, and squared, multiplied by what? Multiplied by 3.5 equals to. Okay, answer in decimal. All right, so this gives us 0.10115. This is the answer to the problem. So, and all right, what else do I need here? So this is just the required answer to this problem as we have it in the question. As the required answer to the word, to the problem. All right, so then the next question there, problem II, is what? It's talking about the time it takes the turntable to what? The time it takes the turntable. If you read the question there properly well, sorry I have cleaned it. The question says, calculate the time taken for the turntable to come to rest after it is being switched off. Calculate the time taken for the turntable to come to rest after it is being switched off. That is the next thing we want to calculate. Now, for us to calculate the time of motion, the time of motion can be calculated by using the kinematics of rotation. The kinematics of rotation can be used to calculate the time of what? Rotation. Because if you can remember, the kinematics of rotation are, number one, we have W equals W naught plus what? Alpha t. The other one is what? Number 2, we have what? We have theta equals what? Equals W naught T plus half alpha T squared. The other one is what? Number 3 is what? We have W squared equals W naught squared plus what? Plus 2 alpha what? Alpha theta. No? Which can be compared. All these things can be compared to linear motion. This one becomes V equals U plus AT. This one now becomes what? This one becomes theta is what? Theta means displacement now. We can use X equals what? UT plus half AT squared. Then this one now is what? Is now V squared equals U squared plus 2AX. I believe you know all these things. So the only one you're not familiar with is the equivalence of all these kinematics in what? In the world of rotation. So all these things, these are the equivalents of this. So what we will do is that to calculate the time, that is to find the time taken before the time it takes to come to rest. We have to make use of any of these kinematics that makes reference to what? To time. Now we have two kinematics here, two equations that makes reference to time. This guy here and this guy here. But I believe that this one will be easier for us because to use this now, we must know the what? The final angular velocity. It was given to us in the question. We're also given the what? The initial angular velocity. And are we giving alpha the acceleration? Are we giving alpha? No. Okay, we also have on that one, the fourth one is what? The fourth one is distance covered is theta equals what? The average velocity, which is W naught plus W over 2 times what? Times the time taken, T, to cover this displacement. Which is equivalent to what? Which is equivalent to X equals U plus V over 2 times T. I believe you are all familiar with all these things. If you really studied your kinematics of linear motion very well, you shouldn't have any problem or any challenge in the world of rotation. So you can now see that the best kinematics or equation of motion to be used here is this last one. Because this one now, here, we talk about time. We want to find the time. Our initial velocity was given. Final velocity is given. Theta is given. Theta is 3 revolutions, which I said that we can convert that 3 revolutions to what? To radians, which is the standard unit. So now, I'm going to make use of these kinematics to solve or to find the what? The time required for the what? For the turntable to come to rest. So I can now come here and say, using the kinematics of rotation, using the kinematics of rotation. That is the equation of rotation given as what? Which is given by theta equals W naught plus W over 2 times what? Times T. Multiply, this is T, please. The time. We now say where, watch me please, where W naught was given as 3.5 radians per second. Our W was given as what? 0 radians per second. What again do we have? Theta was given as what? 3 revolutions. And I have told you that if you are given the angular displacement, the measurement of the angular displacement in revolution per seconds, or let's just say in revolutions, you can convert it to what? To radians. Because the standard unit of angular displacement in the world of rotation is what? Is radians. That is the chosen what? The chosen unit. You can measure angular displacement in various means. In degrees. Angles can be measured in degrees, in radians, in revolutions, and the rest of them. But the chosen standard unit in physics to finding the what? The units of angular displacement is what? Is in radians. So this revolution, we have to convert the revolutions to what? To radians. Because 1 revolution equals 360 degrees. And 360 degrees equals what? 2 pi in radians. So 1 revolution will be equals to what? Will be equals to 2 pi. So this now becomes equals to 3 times what? 2 pi radians. By what? Radians. So if you multiply this now, I think this will give us something like this. It will give us 3 by 2 is what? Is 6. So this now becomes 6 pi what? 6 pi what? Radians. So we are going to induce all these values we have now into this formula. So this now implies by introducing all these things into this formula, we now have our theta now becomes 6 pi. Will now be equals to, what is W naught? 3.5. Plus, what is W? 0 over 2 multiplied by what? The unknown time, t. And this now implies that what? This now implies that 6 pi is equals to what? 3.5 over 2 by what? By t. We now cross multiply. Cross multiply. Well, I don't have to write that now. Okay, let me just write it for those who are just learners or beginners. Cross what? Multiply. If I cross multiply this relation, what I now have will be what? This time it gives us what? Okay, we'll have 3.5t will be equals to 12 what? Pi. 12 pi. So by so doing, to find my t now, I have to divide both sides by what? By 3.5. You can see that 3.5 now is married to what? To t by multiplication. So therefore, the only way 3.5 can leave t alone is by what? By divorce, which means dividing it by what? 3.5. So this now means that what? That my t alone, this means my t alone will be equals to what? 12 pi over what? Over 3.5. Which invariably means our time t required will be equals to what? 12 by, what is the value of a pi? According to Pythagoras. Pi is equals to what? 3.142 over what? Over 3.5. So this now implies at the time t, if you now do your rough work using your calculator, I think I have mine here. The time I have is what? Is 10.77 seconds. Now, most of you may be thinking at home that we are playing here or joking. No, this is not a joking matter. Because most of these questions you see us solving here might even be, there is every possibility that you are going to see these questions in your exam. So do not joke or do not play with these things. We are trying to see how we can possibly help you to understand these things so you can go to your exam hall and write your exams by yourself. That is what we are actually doing here. So what it means is that it takes the turntable or the disk a time interval of what? Of 10.77 seconds to what? To complete 3 revolutions, or to come to what? To come to Rex. That is what this question is asking us to find, and we have done that. Then the third question, the question is so broad. We also have the third question, so you can digest this properly well and see what we have done. I believe that it was clear and well understood. All right, the third question. The third question says we should find the moment of inertia of the turntable about its axis. That is II. We want to find the what? Moment of what? Inertia. The moment of inertia of the turntable about its axis. But I believe that the moment of inertia, the turntable is what? Is taken as what? As a disk, isn't it? You can say taking the moment of inertia, taking the moment of inertia about the center. The moment of inertia about the center of gravity will simply be equals to 1 upon 2 mr what? Squared. Be 1 upon 2 mr what? Squared. So that is what we'll be using to solve all right, the moment of inertia about the center for a disk, as we are using here, the question talks about a disk. So it's given as half mr squared. So of course, I have the mass of the disk, where, you can even write it down here, where the mass of the disk M was given as 2 kg, maybe? Yeah, that's 2 kg, I think so, yeah. And then what again? The radius R was given as what? The radius was given as, though we are not given the radius, we are given the diameter D. Radius is normally equals to diameter over 2, which means our radius R will be equals to 34 over 2 which means our radius r will be equals to 17 centimeters as it was given, which means the radius now in meters now be 17 by 10 raised power minus 2 all in meters. So using all these parameters we have now in this formula, it therefore means that the inertia through the center of gravity will be equals to 1 upon 2 by my 2 as the mass times, what is my radius? 17 by 10 raised power minus 2 all what? All squared. And this now means by my calculation here, this will simply give us that the inertia through the center of gravity will be equals to, after resolving, I think 2 can cancel 2 here now. This now becomes, that will give us, I think, 0.0289. If you punch this properly well, I think that's what you are going to get. If there is any correction, that could be done later. All right, so then next, what's the next question there? Question 4, the IV part. It says, question 4 now says, we should calculate the what? The torque. The torque acting on the what? On the table. Yes, remember that before a body can rotate, the torque, there must be torque produced. And torque is equals to what? The force times the what? Times the distance. Torque is simply a force which produces a turning effect. A force with a turning what? Effect. I told you that in the world of translation, force is everything. If you want a body to start motion or to stop moving, you simply apply a force on it. A body undergoing one-dimensional motion. If you want the body to stop moving or to start moving, you simply apply what? A force on it. And that force can either stop the motion or what? Or start a motion. But in the world of rotation, force is not everything. It is not actually the force you apply that produces a turning effect or that makes the body to what? To rotate. You may apply as much force as you wish, but still, that body will still refuse to what? To turn or to rotate. It is the torque that produces a turning what? Effect. So in the world of rotation, torque is everything. But in the world of translation, force is everything according to Newton's law of motion. F equals ma. So now, we wish to solve the fourth question, which makes reference to what? To torque. If you go back to that dictionary we gave to you, when we treated the dynamics of rigid body, we mentioned torque. Where we said that torque is equals to what? Torque is just the equivalence of a force in the world of rotation, where torque equals I times what? Alpha. That is the product of the moment of inertia and the what? And the angular what? Angular what? Acceleration will give us our what? Our torque. Yes. So of course, it was mentioned that torque, remember, okay, if you want to remember, let me just remind you. Now, in linear motion, force is equals to what? Mass times what? Acceleration. But in rotational motion, force is replaced as what? As torque. Force is what? Replaced as torque. And this torque is simply equals to, now, mass. I repeat again, mass in the world of rotation is replaced by what? By inertia. So have I as inertia. Then acceleration is replaced by what? By alpha. So torque is equals to what? I what? Alpha. Now from question I, we have the value of the inertia as 0.0289. But what we don't know yet is what? Is the value of alpha, which has to do with our angular what? Acceleration. So how can we find the angular acceleration? Very simple. In the same vein, the angular acceleration can be found by using any of those kinematics of rotation, which we have given to you. So, for us to find the torque, we must know the what? Angular what? Acceleration. So let us see how we can find our angular acceleration. So, I repeat, torque is equals to I what? I alpha. I alpha. Let us call this equation star. 1 star. Because we're going to use this equation star now to find the value of the torque. But we don't yet know alpha. But this alpha can be found by using any of the what? Any of the kinematics of rotation. I have given it to you separately. The first one is W equals W naught plus alpha t. Second one is what? Theta equals what? W naught t plus half alpha t squared. The third one is what? The third one is W squared equals W naught squared plus 2 alpha what? 2 alpha plus 2 alpha what? 2 alpha 2 alpha what? Alpha theta. Then the last one is what? The distance covered, theta equals W naught plus W over 2 times what? Times T. So now if you look at these things clearly well, we will notice that the parameter that we can use this can be used because we have the time it took to complete the whole revolution. I may decide to use this or I may use this one. So any of them can be used. But in this case, remember that the turntable was moving with a particular speed, an initial speed. And then, after completing 3 revolutions, it now came to rest. The speed, the final speed now became what? 0. From a speed of 3.5, from a speed of 3.5 to a speed of what? Of 0. Can we say the body is accelerating or decelerating? The body is what? Decelerating. That is, the speed is what? Slowing down. The body is slowing down in what? In speed. So instead of using, so in that case, now talk about deceleration. So instead of using here as plus, because our alpha has to be negative now because the body is decelerating. So instead of using plus, you have to use a minus here. Because if we use plus here, at the end, we're going to result into a negative value of alpha. And that will also indicate that the body is actually what? Decelerating. So we have to use the what? Let me use this one. Let me make use of this one here. I think that would make it clearer. Yes, let me use that to solve this. So I can now say using the kinematics of rotation, which we have as what? As W squared equals what? W naught squared plus 2 alpha theta. Where we have our W, where W equals what? 0. W naught equals what? 3.5. And then theta is equals to what? Is equals to 3 revolutions, which we now converted as what? As 3 times 2 pi, which gave us 6 pi as a whole. So inducing all these things into this formula, this now implies that 0 squared will be equals to 3.5 squared plus 2 alpha times, what's my theta? 6 pi. I think this now gives us 0 is equals to 3.5 squared will give us what? I think that will give us 7.0 thereabout. 3.5 squared will give us, okay, 12.25 plus 2 by 6 is what? 12. Alpha what? Pi. Okay, the value of pi now is, okay, let's just put alpha pi anyway. So this now gives us, I think this guy will come to this side. Let me bring this guy to this side. So this now gives us minus 12 pi alpha is equals to 12.2 what? 5. This now means that what? Our alpha alone will be equals to what? Are we having minus? No. Oh my God. So we're using minus, I said here. This is minus because the body is decelerating. So talk about negative acceleration. This is now minus. We use here. Minus. So here will give us what? I think this come here becomes plus, please. So our alpha will be equals to what? 12 by 2.5 over 12 pi, which now means our alpha will now be equals to 12 by 2.5 over 12 times, the value of pi is what? 3.14 what? 2. And I believe that if you now resolve this critically well, your alpha will now be what? Let me punch this. This will give us 12.2.5 all over 12 by 3.142 equals to, all right, and I have this as 0.325 radians per second squared. Radians per second squared. Now, this is just the value of alpha. The value of alpha is not actually the answer to the question. We are asked to find the what? The torque. So we're going to use the value of alpha in equation what? Star. So we can now say, remember, from equation star, we have that the torque, which we are required to find, is equals to I alpha. And from the previous questions we have solved, I think in question II, we have been able to calculate the value of the what? Inertia. Can I say where we have found the inertia through the center of gravity as what? As 0.02 what? 289. And then here we have our alpha here. So introducing these things into this parameter, that now means that the torque will now be equals to 0.0289 times 0.325. And this now means the torque will now be what? Let's see what we have. 0.0289 times 0.325 equals to, so have this as 9.3 times 10 to the power minus what? Minus 3. So this is the required solution to this problem. Do we still have more of the questions there? That's the last question we have in that particular note. So like I said initially, these things we are solving, they are not just, we are not joking here, we are actually serious by trying to see how we can provide the solutions to all these things. This part of physics is very, very what? Critical, and it needs professionals to handle it. You don't just handle it if you are not actually rooted in the field. So for me to handle this shows that yes, that it can easily be what? Be dissolved. So please, follow us up as we solve all these examples. All these things are exam questions, so one should easily, practice them and make sure that it sticks into your what? Into your veins before going for your exams. So thank you, and keep on subscribing and keep on watching more of the videos as we keep on sending more of the videos in the other subjects or topics that we have not yet treated. So thank you, and God bless you.